Well, hello, my name is Curtis Bloom. Actually, a scientist, a former biochemist, and I often share a story about experiences I had doing research. You may remember the OJ trial, so a lot of people have very strong opinions about the OJ trial, but you may remember that DNA sequencing was a huge issue. Back then, DNA sequencing had issues that needed to be solved, and you may remember that they used that excuse to say, you can disregard the DNA evidence. But you really don't hear that anymore. Everybody seems to trust DNA sequencing, and if you ever wondered why that is, it's kind of the story of some research that I did back at Caltech years ago, and in combination with a company called Applied Biosystems, based out of the Bay Area. They are the world's leading DNA sequencing chemistry company in the world. I worked closely with them. So when I finished my PhD at UC Riverside, I was a protein structure function guy, and I worked on insulin. I had a discovery that is used for every formulation of insulin. Kind of explains how small molecules bind to insulin and how the structure relates to the function. So in that case, it's a binding protein. But I ended up trying to solve a question about how these small molecules interact with the protein complex. It's actually it's a hexamer, so there's 6 monomers of insulin that come together, form a structure that's got symmetry to it. Long story short, in the end, I ended up writing an equation that explained how changes in the structure and binding of molecules were related. So from that, I wrote to a bunch of campuses, trying to see how can I apply those skills to, say, a problem that exists in science or in industry involving proteins that needed a solution. This was right about the same time that the OJ trial was finishing up. And I stumbled across an interview with a professor at Caltech who offered me a project of redesigning the enzyme that's used for DNA sequencing, Taq polymerase. It's also used for PCR, polymerase chain reaction, which is a way of copying pieces of DNA using primers. Anyways, the technology from PCR was used to take the incorporation of fluorescent labeled terminator nucleotides. So as you're growing a chain of DNA, if it incorporates one of these terminators, it would have a specific color for A, T, G, or C, and the chain would stop growing. So in the end, you take a solution of a whole bunch of different length pieces of DNA, run it on a gel that separates all of the strands by length, and so you get a length to color correlation, and that color correlation can be translated directly to the sequence. So back at the time of the OJ trial, there was an issue with the enzyme as it was, that it had trouble incorporating nucleotides, especially in GC-rich regions of DNA. So on average, you could get about a 350 base read on sequencing, and if it was GC-rich, sometimes you couldn't even get that. So the sequencing was good, it was tedious, it was more expensive at the time, but the need to go in and change the enzyme to allow the terminator nucleotides to be incorporated more easily was something that would really advance the field. So I was brave enough to say I wanted to change enzymes, and found a professor who was the chief scientific advisor for the DNA sequencing company, who needed somebody to come in and do exactly that. He wasn't able to find anybody else, and I was there and ready, so we took a project on.
Why couldn't he find anyone else?
I think it was probably career suicide to take on a project of that scope. The odds of failing seem to be way exceed the odds of succeeding at it. And the person who was at Roche Biochemical, they were the owners of the Taq polymerase enzyme. They kept hold of the ownership of that very tightly, as would be expected. It was a huge moneymaker for PCR and for DNA sequencing. So he believed that he could come up with the answer by random mutagenesis. But random mutagenesis, you're going to basically create mutations at every position on the amino acid chain. There's 19 different ways to change each position, and there's 832 amino acids in Taq polymerase. So that's 19 to the 832nd power random possibilities. It's a number that defies comprehension. It's so astronomically huge.
And for the viewer, just so that we remember, this is all leading up to improving the sequencing, correct?
Yeah, so,
Yeah.
I mean, the goal obviously would be to find a mutation to the enzyme that would allow incorporation of these nucleotides, which are only used for sequencing, and they certainly wouldn't be a good thing to incorporate in a living organism. So the enzyme has to be incredibly accurate. And in order to do sequencing, you're asking the enzyme to incorporate things that it wouldn't naturally allow in. But it worked. I mean, it's functional, but improvements were definitely something that was desirable. So my goal was to basically make the enzyme read right through any sequence, and to do it to the point where you could extend the length of the read. I mean, go to 500 base pairs on average, 750, that would be great. So my approach was to build a model based on human polymerase, which we had the X-ray crystal structure of, and we knew that it was 80% identical to the enzyme from Thermus aquaticus, which is a bacteria that lives near heat vents, so it actually lives at a very high temperature. So the enzyme had evolved or was created to, excuse me, it was evolved or created to live at a very high temperature. So if you put it in solution, you heat up the solution to boiling temperature, and then cool it back off, the enzyme is actually still functional. Human polymerase would denature and would become non-functional. So in the polymerase chain reaction, to amplify a particular sequence, you have to cycle it. You have to heat it up, get the DNA to separate into single strands. You attach a primer that gets extended, and then the whole thing comes back together with the enzyme, makes a copy. Then you have to heat it up, denature it, separate it again, have it come back together with new primers. Anyways, in the process, it amplifies the DNA that you're desiring based on the primers that you had. So that enzyme allowed them to basically run a sequencing reaction without having to add enzyme every single cycle. So I took that enzyme, which we knew 80% of what the sequence was, and we knew what 80% of the structure must look like based on its identity to human polymerase, and I had to predict what the rest of the chains were doing. What did the structure look like, because we didn't have an X-ray crystal structure for that. So the other thing is, if we make a mutation to it, we have to make sure that it doesn't kill the enzyme or destabilize its thermostability. So I set out to identify, by building a model of double-stranded DNA with single-stranded coming off where it would be extended, and we knew that that had to bind to the enzyme, and it had to incorporate an incoming nucleotide. So I built a model, and it didn't exist before that, that also allowed for the incoming nucleotide with a fluorescent dye to sit on the enzyme. The enzyme looks like a right-handed model. It's got fingers region, thumb region, and a palm region. And nobody knew if the double-stranded part sat in the palm, or if the double-stranded was here, and then the single-stranded comes across the palm, or if the single-stranded is just out in solution. Well, after building the DNA complex with a nucleotide and docking it into the model, it became pretty clear that the only way that made sense was that the double-stranded sat in the palm region. And that also explained why, if you had a GC-rich region, it had trouble sequencing, because it's communicating with the enzyme. If the double-stranded is out here, there's no contact with the enzyme. It didn't make sense to me. So that was the model that I went on. From that, I predicted 52 sites on the enzyme that could interact with the incoming nucleotide. Fluorescent dye is sitting out here. And all of these sites that were in here, of those 52 regions, we came up with 300 specific mutations to test. And in the first 15 mutations, we had positive results in the first, and we had 6 out of the first 15 that had positive results. So it became clear that at least the model I was working on had potential, that it would come to an answer at some point. Well, long story short, in the end, it turned out to be a combination of changing the chemistry, like the linker arm and the fluorescent dye that's attached to the terminator nucleotide, and two different mutations that they complemented each other. So one had the properties of incorporating some of the nucleotides better than others, and the second mutation had exactly the opposite. So the ones that were difficult for the first were easy for the second. And mixing those together came up with a solution that when you ran the reaction, you got a 1500 base pair, nice clean read, didn't matter what the sequence was. And ever since then, nobody argues that DNA sequencing, can't be trusted. It can be. It's actually greatly improved. What I didn't realize with all of this, that making DNA sequencing cheaper, more efficient, that there were companies that came up with this great idea of, hey, if you send in your DNA sample, we can tell you about your ancestry, because they could run these sequencing reactions fairly cheap and find out all kinds of stuff about you. Well, in the end, they ended up creating a DNA database for everybody that sent in their samples.
And I'm sorry, what year? Like what year did this start? The whole DNA database thing.
I want to say it's been about 10 years, but
okay.
In terms of the database, it could even be more than that. But once the database was populated enough, there were some amazing forensic scientists who said, we could search the database, compare that to DNA evidence that we have, and start to identify people. And obviously the most famous early case that was solved was the Golden State Killer. When I was growing up in Northern California, we lived not too far from where they called him the East Area Rapist at the time. But he terrorized our neighborhoods, and I was always fascinated with forensics, something that I wanted to get into, law enforcement, but it wasn't for me. I ended up going to school for botany, psychology, ended up as a biochemist, and in the long run, it turns out the discovery that I made with DNA sequencing, alterations to the DNA polymerase used for DNA sequencing, ended up inadvertently leading to the database that
that's what I was wondering.
The guy caught. So
yeah.
Persistence does pay off. It is something that along the way I met with a great deal of resistance. A lot of people who believed there's just no way that you're going to be able to solve this problem using a design approach. We had results within 6 months of starting the project that we were on the right track. So
what made it different? What made your approach different than everyone or the people around you to actually find the solution?
Doing it by design. So protein folding.
Without going into too much of the science, but just rather
methods of trying to predict protein structures were really in their infancy at that point. So there were a lot of people that were trying to figure out ways to predict how a protein is going to fold based on its sequence.
Okay.
I don't even know how far they've gotten on that to these days, but that was one approach. But it was so early on that nobody really felt brave enough to say, "Oh, I'm going to design a change," or "I can predict how the protein is going to change based on a mutation." And of course, random mutagenesis, just to generate a bunch of mutations, even targeted random mutagenesis, had all kinds of complications. And the biggest complication is, how do you screen large populations of a DNA sequencing enzyme? You have to purify it, run it through all the tests to actually see what its sequences look like. And then how do you identify one that's actually got a specific change that you're looking for? A lot of complications there. But to approach it from just random mutagenesis, the sheer numbers of what you'd have to test in order to find an answer were just insurmountable.
But what was your approach, and not the scientific part of it, but like, how did you were a conduit to make this discovery? Like, what was the breakthrough for your,
Yeah, what I brought to the table was the idea that I could actually predict by design what the change is going to be. And I invested a couple of years of my life proving it, but the reality is I could have easily have been overreaching. But right place, right time. right connections. The only way that we had the right to work on the enzyme, because Roche was not going to let anybody work on it, because they have great value in the ownership of that, and they don't want somebody else to discover it. And there's a lot of people in the field that feel like they got to be the one to discover it.
So it was like a race, also, right?
Well, it definitely was a race, and we didn't know who was in competition with us, because who knows who else is working to try to solve the problem. And you never really know until after the fact. So you may come up with a discovery, send it to the patent office, and then find out, oh, somebody else is a couple years ahead of you. That's just the scientific race. That's what's out there. In my case, we got permission to do design changes because since Applied Biosystems had agreements with Roche, they couldn't just go and work on the enzyme without the permission of Roche. And they said, hey, if you're going to do it by design, there is no way you will ever have success, so knock yourself out. Go do it. One of the funny things was after we had already identified that we had mutations that would be likely beneficial, we had filed with the patent office, so we had a patent pending. We made it known that we were pursuing this project and we had made some progress. And one of the scientists from Roche stood up during the conference and said, there is no way that this will ever work. You're wasting your time. It's a joke. He sent one of his employees immediately after that conference to pull me aside and say, hey, we know this isn't going to work, but we want to know if you would be willing to come and do it for us. And I thought that was hilarious, because I said, it's not going to work, but you want me to come try to do it for you. Not knowing that I had already, we had already found the answer. We had identified probably what was going to be the case. It took several years to develop, the exact answer that would be something put on the market, but we knew we were on the right track. So there was an additional group that tried to sue us over ownership of it, but the whole thing was ridiculous. When they went to the patent office, they found out we were years in advance of what they claimed, and they hadn't had any provenance on it. Having an idea for something isn't enough to just say, I thought about this, so therefore I get to have a patent on it. You actually have to go out and prove that your idea actually makes sense, and we were able to do that.
We talked about this off camera. I said, well, what are the implications? But you said, well, they've already passed.
There's a lot of
implications. Come and gone.
The ethics behind this kind of information, because what do you do with the ability to have somebody's DNA sequence? I mean, there are many sequences that they know correlate to your likelihood to get particular types of diseases, cancer, whether or not treating cancer in a particular way, if you have a particular sequence. There's a lot of valuable information in having a database of people like that. But, one of the ethical questions is, what if an insurance company says they have all this information on you and they know that you're going to be a very expensive risk to insure? What if they use that to exclude you and they only want to insure people that have, whatever the good sequences correlate with what you have?
They do this presently, do you think?
I don't know. I really don't know. I know it was dealt with questions about pre-existing conditions. So, but the ethics and the science are constantly playing leapfrog. So at that time, certainly the question was, what if we advance the science and the ethics haven't been dealt with? It's ripe for abuse, of course. I never really realized or predicted that they would take your DNA and create a database, even when they were saying, hey, find out about your ancestry.
Oh, that never occurred to you back then?
Well, I wouldn't think that they would take your actual sequence. I thought they would find certain things that were markers for your particular ancestry. But to develop a database that could identify people out of a population, in hindsight, seems perfectly sensible. But you see stories every day about how the DNA database has affected people. I mean, I saw a story about two sisters that were separated for 80 years. They were unable to find each other, and yet through the database they were reunited. How many people have been convicted or exonerated based on DNA evidence? It's had a dramatic effect on people, and to think that I was able to contribute that, to me, in hindsight, it would have been nice to think that that's what I was looking to do. But it's it's just been a real pleasure to be able to have contributed in that way. And on that note, I don't feel like any of that was an accident. I feel like I was put in the right place, right time, and given the right skill set to make sense of it all, put it all together, and come up with an answer. And of course, a tremendous group of people that I was surrounded with that were just brilliant and helped me advance what it was that I was doing. As a collaboration, to me, it was one that I may never experience again in life, but was pleased to be part of it. And I think overall, I feel like it's been a definite benefit to the world, and something that I'm sure I will benefit from in many ways in the future too. But
so I have two questions. If we went back around to the O.J. Simpson trial, like, what would you?
Well, I think even at the time, to me, as a scientist back then, there was enough information to say that his DNA was there. Of course, even with that kind of information, I mean, you see situations now where they have video of a person committing a crime, and they can still question, but is that really a crime, or is that real? So, the existence of the information, I think it may have changed things, if they had the improvements to sequencing, but I think they would have still had the same arguments, and emotional arguments can win over facts.
Well, you mentioned off camera too that the those who control the information, right, regardless of a scientific effort or any other kind of effort, it's about controlling the information, I guess.
Well, if somebody has access to, like, your DNA, and they can put that DNA, whether after the fact or before the fact or during the fact, in a place where it says, hey, you were there, even though you weren't there, that can be misused. It all depends on how information is handled. So
the other question I had is, can you give examples, like you talked about the two sisters? Can you, like, other direct examples?
Well, there's tons and tons of examples of people exonerated on DNA evidence since all of this has come about. So just the improvements of DNA sequencing, massive in the forensic field. So I don't think you can find a lack of examples out there. I think they're everywhere.
Yeah. And where are you headed? I mean, you're a motorcycle enthusiast.
Definitely a motorcycle enthusiast.
You're into photography. That's
restoring motorcycles.
By the way, he's an amazing motorcycle restorer.
Yes, BMWs.
BMWs.
Yeah, it's the R1200C specifically. That's my extreme hobby for sure.
That's how we met.
Yep.
Yeah.
Meet a lot of great people that way.
Yeah. As far as your relationships, like now, fast forward to where we're at now. It's like you're applying skills that you've had, that you've learned, that you've educated, through education, and primarily it seems like being inquisitive, just inquisitive.
Yeah, I think there's a common theme in the way that I have approached things my entire life. I'm very spatial mechanical, also a very emotional person. So
you are?
Yeah. It's kind of an odd combination, but I have a tendency to approach things from a very sort of, I just love mechanical things.
I'm waiting for the tears to roll down your cheeks. Okay, it's not going to happen.
My protein work, they're basically little machines. Motorcycles, I love it. I've always been into model trains, building things. I used to build go-karts as a kid. Anything where I'm using my hands, and I love to figure out how things work. So who knows what's next? I mean, motorcycles today.
But ultimately, it's these activities that you pursue. It's I think you mentioned it earlier. It's about the connection, like the people you meet,
Absolutely.
And forming the relationships that are.
Yeah, I'm very much drawn to, the sorts of things that I can do, but how I relate to other people.
Yeah.
So those kind of things open doors, give me opportunities to interact with people.
Was it like that when you were when you were in the science field? Were you developing relationships like that, like you are now? Or
there were a few, but I met with a lot of resistance too. There's a lot of people out in the academic field that are they're very book smart. They're very focused on, learning everything about everything, and not necessarily so much about people skills. So that's probably why I didn't pursue academia. I'm much more of interactive. I really like applying my skills to specific tasks, as opposed to teaching the same thing over and over again.
Yeah.
But no, it's something I've considered. It's definitely something that I might pursue if the opportunity arises.
Do you think science needs those types of scientists that are so focused on, they isolate themselves, or do you think it would actually benefit science or science, let's say, for them to like you, being more people oriented? What do you?
I think the laser focused idea. I mean, to really get in and understand something, you have to be able to think past what people already know. You have to go to the next level and figure out something that people haven't explained yet. In that respect, I have so much respect for professors, scientists, teachers, people who have those skill set to really teach people how to think about things. But the world needs people who can say, yeah, I know that's what's been done so far, but I need to approach it from a completely different direction and maybe see what it is that makes sense that maybe nobody's put together yet. I've been fortunate twice to be in a position where I was at the forefront of something that people had observed but couldn't explain, and kind of the perfect storm. Everything came together, right place, right time, and I was able to see something that wasn't apparent to everybody else and put it together.
I think a lot has to do with how receptive the person is at that moment too, at that time.
Oh, absolutely. Yeah, it's very hard to clear your head from everything else, every distraction in the world, and focus on one specific thing. And for a time in my life, that was something that I was fortunate to be able to do. And yeah, I may never get the opportunity again, but if I do, it's something that I'm drawn to. So maybe in the future.
And I guess we could say we're coming to a close here, possibly. But before we do, I have one big question for you. You ready?
I'm ready.
When do we get to go on our next ride?
Soon. I'm just today.
It's been a year.
Wrapping up another sidecar, and
describe that a little bit.
Well, I've been working on the BMW R1200C, attaching sidecars to them. I just built my third one. The big challenge was the way that the bike is designed. The engine is the center of the bike, as opposed to the engine being mounted to a frame that's the center of a bike.
Yeah.
So in the front, you can't just directly bolt to the engine without potentially shattering it with a good impact. And so I've designed a cage that attaches to the bike that uses all the strongest points of the bike without putting at risk the actual engine case, and then attaching sidecars to them. It's been a challenge, but it's something that definitely I love doing. I love seeing how everything comes together and all the forces, and then learning the skills for finishing all the bodywork, fiberglass, paint, interiors, gosh, you name it. Just to me, anything mechanical like that is it's right up my alley.
Yeah, and then one last thing would be photography.
Yes, I've been a professional photographer for over 33 years. Done thousands of events, lots of weddings.
You have a website?
I do have a website, enchantedportraiture.com.
I can put that in the description.
Very good. Yeah, you can see some of my work there. And of course, if you get on the forums on Facebook, anything with a BMW R1200C, you'll probably find me there. Yes. So, but yeah, that's my life.
Anything else? One last hurrah statement to the world.
I'll put it out there. I became a believer 5 years ago. Took Christ as my Savior, and I thank God every day for my entire life. I've seen Him work in my life. He's given me the skill set that I have. He's put me in positions where I believe He did His work through me. I believe that my discoveries with DNA sequencing was meant to happen, and I know He's used it for good. I mean, Golden State Killer right there. There's a great example. I'm curious to see where my discoveries go in the future, what God's plan is for that, and what God's plan is for me. So I encourage you, if you think that science has all the answers, I used to feel that way too. I've come to understand that there is a creator of science. So,
and you're not it.
I'm not it. I've been blessed with the opportunity to discover many of the laws that were put out there.
I'm just trying to ruffle your feathers.
But
no,
that is part of my journey. Absolutely.
Thank you, Curtis, for taking the time to do this, to share a story.
And I hope my story helps some people in some ways, and hopefully it encourages them to go out there and find out what's in store for them, what they can do if they just are persistent and believe in it, and follow that skill set, see where it leads you.
It'll certainly help me. Thank you so much.
Very good.